I decided when I was going to start preparing for coming to Devox France that I should become a fluent French speaker. So I watched Beauty and the Beast. Unfortunately, did not help quite enough. As you can hear, I'll be presenting here in plain old American English. My apologies to you. But hopefully we'll get through this together. So I am Lauren Schaefer. I am a software engineer for IBM, and I am from Pennsylvania, which is a state on the east coast of the United States. For those of you who like to live tweet like I do, my handle is up here. I'm Lauren_Schaefer, and I put a couple of hashtags up there in the lower left-hand corner. You guys are probably already familiar with the Devox France hashtag, but I'm also using Intro to Graph today. So let's jump right in. So if you've heard about graph databases, you don't even know what they are, or maybe your colleagues have said, oh, you've got to learn about graph databases, you know a little bit. This is a session for you, so I'm glad to have you here. All right, so here's our plan for today. We're going to ask the big question, what are graph databases and why should you care? Then we're going to get into how to get started, create your schema diagram, how to plan your graph. Then we're going to go through the CRUD operations, create, read, update, delete. You'll get to see some live queries. And then we're going to finish up with my favorite part of graph databases, which is how to build a recommendation engine. All right, so let's go to the big question first. What are graph databases? Well, graph databases are a type of NoSQL database that focus not only on the data being stored, but also in the relationships between the data. So you might be familiar with relational databases. There you have tables. In graph databases, you have nodes and edges. So graphs can be very simple. Maybe you want to graph the devices on your home network, or they could be incredibly complex. Think about graphing all of the users in a social network and all of their connections and their relationships. So how do you make a graph? Well, you start out by picking your nodes. And you'll hear the word node or vertex used interchangeably. They're really the same thing. So your nodes are your nouns. They're your people, places, and things. Then your nodes are connected by your edges. These are typically your verbs, your action words. And in property graphs, which we're going to be talking about today, you can store properties about your nodes or your edges. So that's the basics of what a graph looks like, what it is. The really nice thing about graphs is that you can traverse a graph. So traversing a graph basically means to move between your nodes and your edges. So if I wanted to traverse this graph, I could start with the node on the left, and I could say what edges go out from it, and I would find two other nodes. So pretty obvious, pretty simple in this example. But when you get into those huge graphs, that's when you can start using graph traversals to your advantage to really find the patterns and insights of your data. So that's what a graph database is, but should you care? Well, graph databases are massively increasing in popularity. This is a chart I took from dbengines.com, and you can see across the bottom is time since January 2013. And the chart is ranking popularity changes in various various database models. So you can see across the top, that big green line on the top is graph databases. So you might be wondering, okay, that line across the bottom, that's relational databases. Those are hugely popular. So this is charting the popularity changes, not the overall popularity. So relational databases have been popular, they remain popular. That's what you're seeing across the bottom. But graph databases are massively increasing in popularity. So why? Well, graph databases have some very important use cases. And I like to talk about them in terms of people, places, and things. I'm all about the nouns today. So let's talk about people. When people shop online, it can be incredibly helpful to see recommendations. You know, other users like you bought the blue pool float, right? So real-time recommendation engines can be efficiently run on graph databases. And you're going to see at the end of the session how you can do that with one simple query. Next use case I want to talk about are places. So graph databases can be used to determine the shortest or fastest path. And things, so the Internet of Things. We live in a smart, connected world, and storing data about devices and all of their connections can be done quite easily in a graph database. Now, unfortunately, when you start combining people, places, and things, a lot of times you end up with fraud. So graph databases are a great way to detect fraud. So let's talk about some examples. Let's say that, if somebody goes and they charge a 1,000 euro charge to a credit card, your credit card company is going to flag it, no problem. But if somebody has a big scheme and they're charging $3 or $4 to a bunch of people credit cards, you might not catch that right away. And that's where graph databases can come in. They can search for those patterns. Another example of fraud is insurance fraud. So let's say a doctor is subscribing prescriptions to users in one location, then he starts doing other prescriptions or procedures for people in different locations or something that's outside of his field. Graph databases can help detect that. And there are tons of more use cases that are very popular. I'll just list these real quick. Modeling social networks, diagnosing psychoses with word analysis, analyzing the spread of epidemics, modeling a bionetwork, or visualizing a social, economic, or political network. So, should you care about graph databases? I think so. In this connected world where we need to do more with our data than access it, graph databases give us the power to gain the insight and find patterns in our data. All right, so this is tools in action, so we want to actually try a graph database. So there are lots of options out there. Apache TinkerPop is an open source graph computing framework that's very popular. It can be kind of a pain to set up because you have to set up a lot of underlying technology, things like Elasticsearch, Cassandra, HBase. So I'm going to be using IBM Graph today, which you've probably heard of software as a service. You can think of TinkerPop or you can think of IBM Graph as TinkerPop as a service. So there are lots of reasons why you want to use IBM Graph. It's managed 24/7. It scales seamlessly, but the reason why I'm going to use it today is because it's very easy to set up. So once you've decided your technology, it's time to plan your graph. So today I'm going to be walking you guys through a sample application that I wrote. It's called Lauren's Lovely Landscape. This is a screenshot of the home page. It's where I sell prints that my husband has taken on our travels around the world. So this is a home page. Let's say you clicked on the Alaska print. It would take you to the page showing you more information about the print. You could see it bigger, and you could click Order Print. And finally, it's going to take you to the order details page where you can put in your information and order the print. So how would we make a graph for this application? The first thing we want to do is model our nouns and verbs. So what are my nouns here? People. My people are my users, so I'm going to make a node or vertex for user. Places, I don't have any in this case, but I do have a thing. I'm selling prints, so that's going to be my other node. And the way we're going to interact between the user and the print is that a user is going to buy a print. So my verb is buys. So pretty straightforward there. Next thing I want to do is define my vertices and edges. So I've got my user vertex, my print vertex, and the buys edge. Now I want to define my multiplicity. So how does my buys edge relate to my nodes? Well, I know that a user can buy multiple prints, and a print can be bought by multiple users. So I'm going to set my multiplicity to multi. There are other options I could have chosen, but like simple, many to one, one to many, and one to one. The next step is we want to figure out where we want to store information. So we're going to add properties to these vertexes and edges. So for my user, I want to store things like their first name, last name, username, and email. For print, I want to store information about the print like the name, the description, the price. And for the buys edge, that's where I want to store information about the purchase. So the date time, when the user made the purchase, their shipping information, and the payment method. Now, I wanted to make this really simple. I didn't want to get into a lot of encrypting, so I don't store passwords. I don't store real credit card information, that sort of thing. So kept things pretty simple here. The other thing that I did for simplicity is I did not go through and explicitly state the cardinality of all of these properties. So the cardinality means how many of each property do I want to store. So user only has one first name, so the cardinality there is single, which is default. But if we wanted to have multiple values for a first name or something like that, we could set it to a list or a set. So all of these have a cardinality of single. All right, so the last step for our schema diagram is to set up our vertex indexes. So I could also set up edge indexes, but I only needed vertex indexes here. So an index allows you to search on your graph. It defines your searches. So I've created 4 here: user by name, user by username, print by name, and vertex by price. So I went ahead and set different things about each index. I'm going to go through those quickly. So the first thing you want to pick is which properties you're going to index. So user by name, I'm going to search on both the first name and the last name properties. My other indexes, I'm only going to search on one property, like username, name, or price. The next thing I had to define was whether I wanted the index to be mixed or composite. So composite index is an exact match. A mixed index does not necessarily have to be. So if I want to search for last names starting with SCH, I want to make that a mixed index. If I want to search for prints less than $100, that's a mixed index. But searching for a username, that's going to be a composite. We're just going to do an exact match on that. Next thing is whether we want the index to enforce uniqueness. So a username needs to be unique, so I set that. But a user by name, the first name and last name, don't necessarily have to be unique. We might have more than one user named Jane Doe, and that's fine. All right, last part of the index that we want to set is whether it's indexing only one particular node or edge. So I can be pretty sure that the user by name is only going to search my user nodes. I feel pretty confident about that, so I'll set index only to user. That's going to make that search go faster. It's only searching the user nodes. But I started thinking about it. What if my site takes off? What if I want to sell more than prints? What if I want to sell mugs, or I want to sell photo calendars? In that case, I'd have nodes for each of those, and I might reuse that price property. So that's why I set for vertex by price. I did not set it to index only. I thought, what if I want to search for all of the items in my store that are less than 100 euros? All right, so this is what I did to plan my graph. PowerPoint is done, guys. So let's talk about how to interact with our graph. We're going to go through the CRUD operations, and we're going to do a live demo. So this is going to be super interesting and fun because I can't see what I'm doing on my screen. So I'm going to be looking up here with you. So we'll see how this goes. I'm going to attempt to not typo anything as I work here. So I'm over here in the IBM Graph Query Editor. I like to use it for demos because it allows me to easily input a query here, and it gives us a nice visual representation of the results. But I'll be writing queries in Gremlin, which is a graph traversal language that you would use with any sort of TinkerPop implementation you're using. And I'm going to attempt to put my schema diagram over here so we can look at it. We'll see how that goes. Okay. So first thing I want to do is do a create. So let's say I want to create a new print for Paris. I've been to Paris. It's gorgeous. Let's insert a new print. So I'm going to start by creating a new graph traversal. And then let's build on that. So let's add a vertex. I'm going to set the label to print. And then I'm going to go down and set all of the properties over here to different values related to my Paris print. I can't read them from here, so I may go in a different order than what you see on the screen. We'll set the name to Paris. We'll set the description to City of Light. Typos are really important here, so if I make a typo, please let me know. We'll set the price to 100. And the image path to paris.jpg. And last thing, we'll set the type to print. I hear murmurs, but nobody's yelling typo, so hopefully we're all good here. All right. Oh, that looks terrible. All right, I'm going to give up on the diagram. So here's our graphical representation of our query results. So we've got over here a print on the right, and on the left we can see the JSON results. We've got our Paris image, the description, that sort of thing. So let me go back to my app's homepage. I'm going to refresh it. Boy. Who doesn't want to see their website on 500%, right? Let's see. Paris? No? You see it? Thank you. All right, it worked. All right, so we did a create. Next up, let's do a read. So let's try and look for the node with the Alaska print. So I'm going to start out the same way by creating a new graph traversal. And I'm going to search for all the vertices that have the label print and search for the name Alaska. All right, my results are up here. So we got one print back, that's good news. Let's see if it's the right one. We've got alaska.jpg, we're in good shape. So there's a couple different ways you can search. So that was a search by name. We could also search by ID. So I'm going to copy this ID. I'm going to modify this query a little bit, delete that end stuff, and I can search specifically for a vertex with a given ID. All right, we found it again. As you can see, the search by ID is very fast. Now let's say we want to know who bought the Alaska print. So let me jump back to the diagram so we can look at it. So we want to search for the Alaska print and then go back along the buys edge and look for those users. So I'm going to scroll down. I'm going to copy a query we wrote earlier that searches for the Alaska print. And then in order to find who bought it, it's actually pretty easy. All we have to do is add the in step. So we're going back in along the in edges. And here are 3 users who bought it. So we can see Deanna, Jason, and Joy bought it. All right, let's do one more read. I'm going to copy this query again. Let's find out what the orders are that contain that Alaska print. So instead of going all the way back into the users, we're going to go in along the edges that contain the Alaska print. In this case, we're just returning a set of edges, so we don't have a nice visual representation on the right, but we do see a couple of different orders. So we can see Jason bought it, Joy bought it, and Deanna bought it. All right, so we did several reads in a pretty quick amount of time there. Next operation we want to try out is the update. So let's say we want to update the description of the Alaska print. We feel like it's not selling very well because of its description. So all we have to do is find Alaska. So I've just modified our query, we keep changing. And then I'm going to set a new property. So let's set the description here to be a smaller description. Again, we can see our Alaska print there. We've got our updated description here, and I can jump over to our app. We can take a look at it, and it's been updated. So it's always nice to get that confirmation there. All right, so we've done create, read, update. Last thing we need to do is delete. So let's say we're tired of Alaska, it's not selling, we're just going to get rid of it. So I'm going to keep editing this same query. So here's my query to find Alaska. And then to delete it, all I have to do is drop it. So I'm going to use the drop step. And I get an empty list back because there's no results when you delete something. But if I head back to the home page, Alaska should be gone. Yep. All right, so we've gone through, yes? That is a very good question. The question was, if I go back to Alaska, will the Alaska page, will it know that it doesn't exist anymore? So let's see. So now it's live update. Thank you for checking me. Not doing any magic here. All right, so we went through all the recommendations. So I'm going to go through now a recommendation engine. So I'm going to go ahead and reset the data just so everything's back to normal. So that's what you'll see me here do here. Oh, so big. Okay, so while that's going, I'm going to jump back to my PowerPoint. Who doesn't love PowerPoint, right? Okay. So, how do you create a recommendation engine? So you've probably heard different terms, maybe you've heard different terms related to recommendation engines. You could hear recommendation or recommender. You could hear engine, system, platform, but they're all referring to the same thing. So recommendation engines allow you to create personalized recommendations for your users. They vary in complexity and accuracy. Some run in real time and some do not. So relevant recommendations can be incredibly helpful to your app's users, which can in turn be incredibly helpful to your app's engagement rate and sales. So it's really a win for everybody. So you might have noticed on the home page we had the top 3 recommendations for users who are logged in. So I'm going to walk you through how I created those. So I started out by using the TinkerPop recipe for recommendations. And the idea in this recipe is we're going to use collaborative filtering. So collaborative filtering assumes that if a user shares something in common, maybe they've all bought the same print, they probably share something else in common. They want to buy another print that's the same. So a major strength of graph databases is the ability to quickly generate real-time recommendations using the concept of collaborative filtering. So let me show you how this works. I'm going to do it in PowerPoint first so you can see the diagram, what's happening, and then we're going to convert it to a single query. So let's say we want to generate recommendations for Dale. So the first thing we want to do is find out what Dale has already bought. So we'll traverse in along his buys edges, and we can see he's bought Las Vegas, Australia, and Japan. Then we want to see who else has bought at least one of those other prints. So I'm going to traverse out from those 3 prints, and I get 3 users, Jason, Joy, and Deanna. So the next thing we want to do is go back in and see what those users have bought. We don't want to recommend things to Dale that he's already purchased, so we're going to exclude those. There we go. And traversing in, we see that there are 2 prints. There's Alaska and Antarctica. So Alaska has been purchased 3 times, and Antarctica has been purchased 2 times. So Alaska is going to be our top recommendation. So let's convert this to a query. And I don't think we're going to be able to see what's going on if I leave the diagram. So, hopefully you took good mental pictures there. So I'm going to start out the same way I always do, creating a new graph traversal. Is all right? Okay. And then we're going to find Dale, because that's how we started in the beginning, because we want to create recommendations for Dale. All right. So let's see if we can find him. Nope. Okay, good news. Things are working. There's Dale. All right, so I'm going to copy this query and just keep building on it until we get our recommendations. So the next thing I'm going to do is label this node as the buyer. It's not going to do anything to our query. It's just going to allow me to reference this particular node later in the query. So if I scroll down, you'll still see that's Dale. All right. So now we want to know what Dale bought. So we're going to go out along the buys edge to find what he's bought, and I'm going to aggregate these together and label them bought so that once again it's just going to be like the buyer. I just want to be able to reference those later in my query. So we can see, oh good, three prints. We can see Las Vegas. We can see Sydney, Australia. And we can see Japan. Okay, so that's good news. Everything's still matching up. So now we want to know who else has bought at least one of those prints. So I'm going to just keep building on this query. So I'm going to go in along that buys edge. And I'm going to exclude, I'm looking for the users, and I'm going to exclude the buyer because we don't care about Dale anymore. And I'm also going to remove duplicates. So it's going to traverse all of those edges. So we could end up with the same user more than once, which we don't need to do. We only need to find each user once. Let's see, so double check the users match. We have Joy, probably Jason, yep, and Deanna. All right, we're in good shape. So now we know who else has bought things in common with Dale. We need to know what they've bought because we're going to recommend those to him. So we're going to go back out along the buys edge, and we're going to look for what they've purchased, but we're going to exclude what Dale has bought. So I'm just referencing that bot that we labeled earlier. All right. So I have here a mess of a screen. It should be Alaska and Antarctica, but it's a little bit of a mess. So I'm going to start at the top and we'll scroll down. So you'll notice we've got, there's an Antarctica and Alaska. If I keep scrolling, you'll see each recommendation listed more than once, and that's for each time that that print has been used. That print has been purchased. User, that doesn't even make sense. All right, so the last thing, yes? Can I show the, I'm so sorry, I'm really struggling. Oh, yes, can I show the path command? Yes. So we're going to use the path step. Yeah. So the path command you can use, the path step, and it'll traverse out for you and show you what all the different pieces are. Unfortunately, in this example, it's a little messy on this screen, but when you get it right, it'll show you, okay, this user bought this user bought this, and it would be connected nicely. It's not so pretty today. So the last thing we want to do is group these together so we can create some nice recommendations. So we'll group them by name. And we can see Alaska 3, Antarctica 2, which matches exactly what we saw before. So Alaska would be our top recommendation. So as you can see, we were able to create a very simple but effective first recommendation engine with one simple query that runs in real time, which is pretty cool. So I am almost out of time, so we're going to wrap up. But basically, if you want to use graph databases when you want to be able to efficiently search for the patterns inside your data. So if you want to access the resources associated with this presentation, I've got a URL here. They're also up at the top of my Twitter page right now. If you want to go deeper and actually try these queries out yourself, play with the app, and really get hands-on, I have a 3-hour hands-on lab on Friday. I would love to see all of you there. Please tweet this out, talk to your friends about it. I'd love to have a full room. You can find me on Twitter, and you can also find IBM Graph and IBM Bluemix on Twitter as well. So with that, thank you all so much for coming, and I will see you around the conference.